Previous session was about App Engine for Business, which is a version of App Engine that's really targeted at enterprise for building internal apps, corporate apps, on top of our cloud platform. But all that stuff, App Engine is what is called platform as a service, where you code to our APIs. There are some limitations to that, like 30-second requests and things like that. But then we scale the app for you. Now, there's another model, which is infrastructure as a service. And at Google I/O 5 months ago, Google announced our first services, infrastructure as a service services, with a twist. So in this session with Simon, we're going to tell you about these new services. The three of them being, yeah, sorry, I really tried to find a quote from the Čvejk soldier, but I couldn't find any mention on cloud or anything. And plus, I have a version that's in French that I'm reading on my Android phone, so I would have to translate it in English. And so I just didn't have time to find one. So what we're going to talk about today is Google Storage for Developer, which is our storage offering, and then Google Prediction API and BigQuery, which are two services for which Google Storage is an entry point. So think about Google Storage as an entry point for your data in Google's cloud. And then you can start using Prediction API, which is our machine learning algorithms, and BigQuery, which is our powerful analytics engine for fast queries over billions of rows. And these services have no equivalent in the industry today. So first, Simon is going to tell you about Google Storage. Simon, all yours.
Thank you very much, Pat. Who was in the previous talk? Can I get a show of hands quickly so I know I don't repeat myself? Okay, right. You'll have seen this slide before. This is about the idea of software as a service, platform as a service, infrastructure as a service. They make up cloud. And as Pat alluded to, we're focusing on infrastructure as a service technologies that Google provides today. I'm going to quickly talk about Google Storage. We just talked about how you build your apps on our PaaS layer. Your PaaS apps can take advantage of our infrastructure APIs. Anyone here using Amazon's S3? Okay. Google Storage uses the S3 API model. But you should think of it as a way of loading your data into our cloud to take advantage of the other services. You can store your data in Google's cloud, as it says here, any format, any amount, any time. You control the access like S3. You use the same S3 primitives. You can then use the third-party tools you're familiar using with the S3 primitives as well. So, sample use cases, there are a few companies which do backup at home and they offload the data for you from a client into S3. Many of us use S3 temporarily out there in enterprise space for development and testing, and S3 is increasingly being used as a storage platform for data in mainstream enterprise applications. What we're using it for is a way for you to bring that data into our cloud so you can use powerful services like Prediction API and BigQuery and your own apps on top of that data. Highly performant, you control the security. It works with the existing security model, easy to use. Okay, it uses a RESTful API. It uses the bucket model. For those of you who have not used this before, you have an area inside the storage that's referred to as a bucket, where you store all your data. Some people implement virtual folders over the bucket, but the primitive that everyone uses is the idea of the storage bucket. You can have up to 100 gigabyte objects, very large. You use keys to authenticate and access this. You usually have a private key and a public key method for gaining control. Only you can get to your buckets using this security model. All the data is replicated to our US data centers, and we're rolling that out globally. The number one question that we get here is, how do rules and how does international law apply to storage of data? That's something that we're working out with our developers right now. I'm happy to talk about that at length, but we can save that for questions. You can use group management and list management with Google Groups. This is a feature which people goes above and beyond the standard S3 model. If you're integrating your apps at higher levels in our platform, you can use the group management to manage a security model on top of that. You could also use, we provide a web interface to the files that are in storage as well, so you can get to them from a web browser interface, and I'll show you some of that in a minute. Okay, I'm going to show you this tool now. I could show you the slides. Would you be interested in seeing the actual tool in action? Can I get a show of hands, or should I crack on? All right, okay, we'll do that. A lot of these slides are formatted to show you just what it'll be, but I prefer to actually try and fire it up and be at the mercy of the demo gods, so bear with me. They got me almost last time, but I had a backup. Tempting fate this time round. Okay. Right, can you see me at the rack? There we go. All right, so there's my command console. I've got some pictures here. I hope this is going to work. Hopefully I've got Wi-Fi. I'll just check I'm wired, and just to remove confusion, we'll switch that off. Have a look here, and here's a picture of the youngest Google developer in my household. Yeah, she's really quite good. Scary. Anyway, she was showing me this demo, and I thought I'd bring it along for you today. So that's showing me the file, right, Rosie Dad, and we have a util that you could go and download called GSUtil, and it's built on top of a library that's publicly available called Bobo, which is an S3 Python library. So it's making use of the S3 primitives. We wrap it and add some code so that, and maintain it so that you can actually use it yourself and extend it there. But there are APIs that you can program against as well. So I'm going to use the programmatic command tool to show you. I'm going to do a copy. Well, first of all, I'll list the cloud, right? If I gsutil ls, it says there's a bucket in the cloud called Simon's Bucket. That's an imaginative name, isn't it? What I did earlier was I configured a file with my secret keys in to access this bucket. It's a text file in the same directory as the command that I'm using. I can't show you the text file because it's got my secret key in it. That was easy, wasn't it? But you can go and look at the format. So gsutil is reading the key. It's going up onto the web. It's saying, show me this bucket. And I can use a set of commands here and say, ls the bucket, please. And I'm going to use a format like a URI. Google storage, that means Simon's Bucket. And there's nothing in my bucket. There's a hole in my bucket. So what I'm going to do now is copy Rosie Dad up to my bucket. It's highly interesting, isn't it? So is this going to work? Don't kill me, demo gods. Yes, okay, so if we have a look, is it actually in the cloud? Oh, look, now it says there's a file in the cloud. Do we believe him? Ah, look, here is the UI tool that the slides referred to for looking at my bucket. And if I refer to this, you can see there's the file in Google's infrastructure. I was a bit quick there, so I'll show you. There's the file. It's available globally with a uniform access speed. We pushed it to Google's infrastructure, and the picture that was on this laptop is now living in Google's data centers, replicated globally, fault-tolerant, available. Thank you very much. Okay, so it's in the cloud, but let's say we wanted to get it out of the cloud again. Google is very big on, I would like to take things out of the cloud or move them around. So because this is a tool that you can use to access S3, you can move files around in S3. So if I say Simon's Bucket, and remember the file was called rosiedad.jpg, right? I can use a different URI to say Simon's old bucket, where I used to keep my things. Oh dear. We'll copy the file up that way. It helps if I actually type the cp command. Sorry. Simon's bucket. Oh, URI invalid. Okay, I'll try again. This is what happens when our demo gods taunt me. I think I typed it right this time. Yeah, there we go. Ah, okay. Well, that's a bit worrying, isn't it? That'll be why then. So I'm trying to push the file up to S3. Yeah. Yeah. So there isn't a file there, so I should be able to say. Oh, I missed the Simon's bucket. That was it. Yeah, blindness. Oh dear. This is what happens when I actually try to do a real demo, isn't it? Oh dear. Too many late nights. Yep. That should work this time. Oh, thank you. Oh, goodness me. That was frightening, wasn't it? Look. Oh, how many more have we got to do of these? Where are we going next? Oh, okay. Right, so fair enough. Just in case you don't believe me, and I made that up. Oh, look. It is Amazon. Fly. Simon's old bucket. Ah, look. I moved the file out of our cloud into Amazon's cloud. Thank you very much. Finally. Now, you can put your data, the idea is that you should think of Amazon, the pricing when you look at Google storage is a little higher than Amazon. And the reason is, only a little bit, and this is intentionally so because we don't want to be a long-term escrow for your data. We think there'll be a commodity market in data. Everybody will use these APIs. There'll be a battle over how cheap that is to store your data for a very long time in a dusty corner somewhere where it's very safe. But we need to be compatible with it. So if you want to use some of the APIs that Pat's going to show you, like Prediction API and BigQuery API, you've got to be able to freely move your data in and out of our cloud with no restrictions. So we've made it so it looks just like everybody else's S3 model. And you can roll your data into our cloud, keep it there as long as you want, a little bit more, do these data transformations on it. But if you want to escrow for a long time, put it away, you can use another service as well. Thanks. Haha, you asked the right question. The question was, surely you weren't stupid enough to be actually pulling the file down from Google and then pushing it back up to Amazon? Yes, I pulled it down to the laptop and I pushed it up. We should have a cloud-side copier, right? And so one of the things we're working on is an App Engine app we were thinking of. I can't promise it'll be there, but we had the same discussion. We should have some services based on App Engine that live in the cloud. When you ask us to copy it to another cloud person, we'll do it on the cloud side, because we have very big connections to all these people, and it doesn't make sense. But what we did here was we pushed it to a bunch of data centers. It was replicating and rolling out. We pulled it back to the laptop, and we pushed it off to Seattle to Amazon. But we did it all from here, which is pretty cool. Thank you. Any more questions? Yes. If you go to the question was, what about the availability for European developers? Up until now, those of you who've had an interest in Google Storage will have seen it says US developers only. Working with the team, there is a link I tweeted at earlier GDDs. I'll do it again. If you send your request, you'll get an account for you to use, and we're provisioning European now. Okay. Tweet me and you will have your account in 24 hours.
Yeah, so to answer that one,
Yeah.
I'm going to show the link now, and we'll tweet it again afterwards. Basically, initially, when we shipped Google Storage as a trusted tester, it's a private beta, it was only for the US. And then people like Simon and I would just go in every country and we explain people how...
Because we have the funny accents, right?
Yeah, how cool these APIs are, and they all want to try it out, and then they were signing up and nobody was provisioning their account. So we talked to the team, and right now there's a link just for foreign countries to sign up there. And when we went to Munich and Moscow before, when people sign up, they get provisioned within the day. So, and we'll just push the link out.
One thing, someone else asked me in the crowd where our storage lives, if it's distributed or if it's US based. It is distributed into multiple data centers and backed up and copied everywhere, I think. They don't tell us
I don't think we communicate on
exactly
where the data resides right now. I think for now it's US only, but there are lots of like front-end services in various countries. So basically, when your browser is going to a file that's hosted on Google Storage, it goes first to a server that's a front-end server that's usually in your country, and then from there it goes very fast in the internal Google network, which is pretty fast, to fetch the resource from a data center that I think it's US only for now. So we don't have the notion of availability zones like Amazon does. That said, there's a great blog post by an independent blogger who measured the latency from many different places around the world of accessing his Google Storage files. And his findings were pretty good. The latency is really good from all around the world. That's one of these differentiating factors with the Amazon offering that Google Storage has.
If you find me afterwards, I'll tell you about what the report says.
Yeah.
Oh, sorry.
Is there a plan to support only European storage? Because, for example, for my application, it's a legal issue to send sensitive data out to the...
Yeah, so the question was, is there a plan to have only European data centers because there's a legal requirement about where my data lives? That's what Pat alluded to as well. At this point in time, we don't have areas you can specify that your data stays within. It is a question that comes up all the time, and hopefully the impression you get from the other talks you've seen is that our products aren't frozen, and we're always talking about it. And that's probably the top question we're getting on this tour at the moment. So I would say stay tuned and participate.
Okay, so I'm retweeting the link from myself.
That's not me swearing in there, is it?
Right now. So that's the link that you should go to if you want to sign up for Google Storage or any of these prediction and BigQuery as well. And I'll put it with a CZ. All right.
I got in trouble because I typed GDDRU.
I saw that.
Earlier. Yeah, I quickly deleted it. But
storage latency. All right, so enough tweeting. Let's talk about prediction. Okay. Yeah, so one of the things that I'm not sure that Simon mentioned, another of the big differentiator of Google Storage is access control. What that means is that in Google Storage, we take care of access control ourselves, which means it's taken care in the browser as well. So you can specify access control lists that are tied to either Google Groups or Google account email addresses. So you can say this file can be accessible only by this group or by that file, and you have an API call to set these access control. And the nice aspect about it is that it's implemented in the browser, which means when you don't need to have a front end doing access control in your application, you can just point your users directly to the files, and access control will be implemented by the Google servers. Okay, so we talked about that. Let's talk about prediction. So how many of you have used machine learning algorithms in your application before? Okay, a few. So the goal of Prediction API is so that next year, when we have a presentation about that kind of stuff, I hope that half the room will raise their hand. Machine learning algorithms are very powerful techniques, especially when you have lots of data. And more web applications are generating tons of data about their users. And very often, developers don't take advantage of these techniques because there are lots of algorithms. They're quite complex. You need to tune them. You need to know them really well. And essentially, you need a PhD in machine learning in order to make use of it in your app. At Google, we have lots of PhDs that have been working on that for advertising and lots of other of our properties for targeting ads and things like that. And what we have decided last year was to say, we have all these techniques that lots of Google apps are using that would be very useful if external developers could just leverage these, and we'll see what they come up with. And so that's what the Prediction API is about. We just package all these machine learning algorithms into some kind of a black box where you just feed your data, you ask Google to just train a model on your data, and then you can ask prediction for it. It's very simple, and you don't need to know anything about machine learning to use that. So that's a nice aspect. The drawback and the criticism I often get when I give talks about that is from people who know machine learning very well. They say, oh, what happens behind the black box? And it's truly a black box, so you don't know what happens. We just give you a quality metrics out of it. So just give it a shot. Try to think about use cases for your own application, how you could use data to make prediction about what your users would want. So a simple example here is you just input a bunch of sentences in various languages, and you tag them with the language which they belong to. Something like that, like English, Spanish, and maybe Czech sentences. Then you ask some prediction on new sentences that are not part of it. So that kind of technique can be applied to lots of different business cases. And the goal of the Prediction API is to democratize machine learning so that you can find some business-oriented uses of these techniques in your application and make your applications better. So this is it's kind of a contrived business-oriented example where you receive some emails and you want to detect which language they're in. So that's the example we showed here. The way the Prediction API and BigQuery work, it always starts with Google Storage. So you put your data in Google Storage, and that's your entry point to the Google Cloud. Then for the Prediction API, you just train a model on your data. And after that, you ask the model to make some predictions. So it's very simple. The model is in the form of a CSV file, so it's very simple, comma-separated value file. So here we just have two values. The first one is the tag, which language is it in, and the second one is the sentence itself. So you start by uploading it to Google Storage using GSUtil, like Simon showed us. And then after that, the Prediction API is a very simple REST API. Yeah, so who knows or who doesn't know what REST is about? Okay. So REST API is an API over HTTP, essentially. So here, in order to train a model, I'm just going to do a post to the Prediction API endpoint where I say, I want you to train. And then you pass the reference to where your data sits in Google Storage, which is a bucket/object name. You pass it as a parameter on the URL. So the training runs asynchronously. It can take 10 minutes to an hour. And so what you can do is you have a REST API to just check the status on it. So when you're doing a get on this, you will just get a JSON structure. For the first 10 minutes, the result will be a training in process. And when it's finished, it will give you an estimated accuracy of your training, which is a number between 0 and 1. And then after that, that's where the fun begins. Here, you can start asking for prediction. So what you do is that you're using another REST API where you ask to query that model that has been created in that bucket, or bucket/object. And what you pass as a parameter in input is a JSON structure, a very simple structure where you pass all the fields in your CSV file, which are called features, except the first one, which is the value that you want to predict. So here we just pass a sentence, and we want the API to give us the language the sentence is in. And this is the kind of output that you get, which is you have an output label here. It tells you, oh, okay, I detected based on the learning I did that it should be French. But also, recently in the 1.1 version of the API, they added the capability for the API to give you multiple labels with various scores associated to them. So it could say, I think it's French 0.99, but it could be English at 0.01 or something like that. And this is an example of a simple Python program to do that. But instead of doing canned example, I think I'm going to show you a real example I built. Before I go to the example, in terms of API capabilities, the input features, what you're putting into your CSV file as an entry, is either numeric or structured text today, so it's kind of limited. And the output is like distinct categories. It's using lots of different machine learning techniques in there. It's called supervised learning, but you don't have access to the tuning or the details of how the algorithms are chosen. It's a REST API, so you can access it from any type of application you're building, whether desktop or web app, or even in AppScript, which is the scripting language for Google Apps. Anywhere where you can access a URL. The API is like App Engine. It's evolving constantly. So it was announced at Google I/O 5 months ago, but 2 months ago they did a 1.1 release with new features like multi-category prediction, the thing I just showed you. Also the ability to do continuous input and mixed, continuous output and mixed input. So let me show you an example I built. I think I even have a slide about this. Or actually, let's forget the slides. So this is my Delicious bookmarks. Anybody using Delicious here? Great, cool. So I've been using it for 6 years. I have categorized 6,000 links according to like 14,000 different tags, because I'm really an obsessive tagger. So I have all these tags in there, and these 6,000 links where every time I read something I'm interested in, I just tag it. And the tags are very personal. If you look at the list here, you have some stuff that look like okay, but like web services and all that. But you have also some of the tags are more like very personal, the way I categorize stuff. Which nobody else would do. For example, okay, what would be a good example? Yeah, so I don't find a good example here. But basically, I have some tags that are really personal, and it's my way of categorizing stuff. And when I saw the prediction API, the first thing I thought is it would be wonderful if I could just train a model on my own data and have then be able to write a Chrome extension that when I'm browsing a news site or a tech article, it could tell me, hey, Patrick, I think you would have tagged it this way. Or maybe it could categorize all the TechMimi articles of a day into the categories I would have applied to them automatically. So I decided to try this out. And again, it's a very imperfect example. I just spent I think like 10 hours working on it, and it's not working very well, but it's promising. And at least it's real code, and so you can see how that stuff works. So I think it's in prediction that I have that. So my first step was to use the Delicious API. Actually, I didn't even use the API. I just downloaded a big HTML file with all my 6,000 links and all the tags. Then I wrote a little Python script that parsed that, and that created like a Python data structure where I had all the links and all the tags. Then I wrote another Python script that fetched all the content, like the full HTML content of all these links, 6,000 links. So I let that run for an hour or two. And now I have this huge file. I don't remember how it's called. I have this huge file which has all my, oh, maybe it's in there. That has all my data, so all my delicious data. Yeah, I think it. And in Python, you can use the pickle format. Once you have built a huge data structure, you just pickle it and you store it on a file, and that lets you like do other processing with that. So I have this big pickle file somewhere. That has all my tags. Essentially, it's called bookmarks.pickle. So it's like 19 megs. So what I'm doing with that after that is that I write this program that grabs all the content of the files, and then I clean them up. And this is the stage where I think my program is not very good. In the cleaning, I use different libraries to try to remove all the HTML tags. The idea is that I want to categorize the content of all this based on like the content of the article. Very often, when you look at articles, you have all the headers and all the sidebars and the RSS feeds and all that. And I think all that like sullies the results. So what I ended up with at the end is something that's called tags.csv. So it's a CSV file. Let me show you what it looks like. All tags. No, it's not all tags.csv. Sorry. I think it was called small tags.csv. So at the end, I end up with a big CSV file that's more than 100 meg. I think it was 296 megs. And the prediction API during the trusted tester is limited to 100 meg per file. So I had to like make it smaller. And I created this small tag.csv file which has, so first is the tag. This is what I want to predict. So here it's an article that I tagged as PR. And then this is the URL of the article. And then this is the so-called clean file. And you see that my cleaning is not very good. And I just changed all the char return and all that by pipes, because I don't care about that in the application. But you can see there's still lots of junk and JavaScript and all that. And I think that's what kind of messes all the system. So after that, what I do is that I push that to my Google storage service, and I do that using GSUtil, and I push that into a bucket called Chanezon. And let me show you my console. So I have Chanezon here, and using GSUtil, I push that CSV file over there. It's called cleantag.csv. No. So cleantag was the big one of 200 megs. The one I pushed and that I'm going to use is called smalltags.csv, and it's 92 megs. So after I've done that, I can use the prediction API, and I think I've done that in a script over there. Which is called train. So I just have a little shell script, and what it's doing is that it's using my authentication token that I have in a file somewhere, and then it's just asking for the prediction API to train on the input parameter, and the input parameter that I give here is I just say train. Actually, I can. Oh no, because I'm doing a post here, so I shouldn't do it again. So what I'm saying here is that I'm telling it, please train on Chanezon/smalltags.csv. And once I've done that, I can check the result of the training. So here I can do check training. So I have another shell script called check training. And here I'm just doing a get using curl on prediction/training/my model. So here I can check the quality of my training. While it's training, it's going to tell me, hey, I'm in the process of getting trained. So let's try it right now. So I can say check training, and then it should be Chanezon /smalltags.csv. Ah, my token expired. Okay. Yes, so I think I need to. I need to do a get auth token. Yeah, I should have done that before. I know.
Demo God's got you.
Yeah, go for it. That's a good time for a question. Go. So the question is, are there any limits on the size of the data that you're putting? Because there's a size of 100 meg limit. Are there some limit in size per the record and all that? I don't think there's a limit per record. But right now, the big limiting factor for prediction is the size limit of the training data of 100 meg. Like even for my very simple example, like my own use, I just couldn't fit everything into one file.
You could have mapped all your long URLs into some hashes, so you could have much more data.
Oh yeah, so this is just a very simple example. I could optimize it in 10 different ways. But actually, that's just to show you what the potential is. I hope that your examples will be better. Okay. Sounds good. Oh. Oh, okay. Yeah, I know. So let me just remove that for a little bit. I'm just going to get back a token. So here I'm typing my email and my very secret password. And clear, and let me clear that screen. And now let's try the, oh no.
Well, okay, while the demo gods are haunting him there, if anyone was in my App Engine demonstration earlier, I have just tweeted, finally deploying my app. So thank you very much. Yes, they're now haunting Pat, but if you go and check myappprague.appspot.com, you can see the actual code I deployed here. So for those of you who are in earlier, you can see your App Engine application running up there.
Okay, so that. Okay.
First person to find it's broken gets a free coupon.
Okay.
Who can see it running?
Oh, sure. Yeah. Okay, I think I got it.
Yeah, slow run.
Okay, so let me just clear my screen. Okay, clear. Okay. Sorry about that. I should have prepared that before. You never know when these tokens are.
myappprog.appspot.com. myappprog.appspot.com.
Okay. So we said let's just check the training that I asked him to perform. So what he's doing there is doing a get on the prediction API URL, then passing the bucket as the bucket/object name of the file as a parameter. And here you can see the result, which is the estimated accuracy of my model is 6%. It's really bad, and I know I need to work more on that example, but I never had the time to do more. If you want to see a better example, Nick Johnson did a very good one where he published all the code for it. It's in Python, and what he's doing is that he's my example, I think, is bad because I'm just taking my own data, just one person. What he's doing is that he's taking all the Reddit posts of all the Reddit users for a week, and then he uses all the subreddits that these users have used to categorize the Reddit. So subreddits are like categories. They're very much like delicious tags. And his results are much better. I think he has a 56% accuracy or something like that. So his is a better example, but this is the one I coded, so I'm going to try anyway. And so let me show you what. So once the model is trained, you just can ask predictions to it. So I have a little shell script called pat_predict. So what this guy is doing is it's fetching the auth token. It's just, I'm going to, so what this script is doing is I'm going to pass it a random URL of an article I'm reading, and I'm going to ask it what is the tag I would have associated to it. So in order to do so, I need to pass, you remember, all the features that I had in my CSV file. So I need to pass the URL, but also the full text cleaned up. So here what I'm doing is that I'm doing a HTML2 text of the input URL. So it's going to fetch the content, clean it up, and then pass all that into a JSON structure where I pass the URL and the HTML, or the cleaned up HTML. And then I'm doing a post of that JSON data structure to the prediction API with my model saying, please give me what would be the category I would have chosen there. And then I'm just printing that. So let's look at, so that's where the demo is very dangerous, because half of the, or I should say 94% of the time it doesn't work. So let's look at this news in TechMeme, or let's take a random one that I haven't read yet. Oh wow, the Beatles. I'm sure I never tagged anything with the Beatles. That's going to be tough. So I'm just going to do a pat_predict. Yeah. With that URL and crossing fingers. I hope it will be like iTunes or Apple or something like that instead of some kind of stupid category that has nothing to do with it. Let's see if it works. So it's doing this post and all that. Ah, here you go. So So RSS biz is it's one of these very idiosyncratic tags that I'm the only one using. I was very interested in RSS a while ago, and this is everything that has to do with a business model around RSS. I don't think the Beatles qualify. Really too bad. So this is a bad example, but that kind of gives you an idea of what you can do with it. And I hope yours will have better quality. All right. So with that, I think that summarizes it for the prediction API. Now, yeah, sure. Quick questions?
Are you sure it's wrong? Because it can actually be right, because in the article there can be something about business, something about RSS.
Let me see. If
Apple is all about business.
yeah, you see, subscribe by RSS.
Did you pay him, Pat?
Thanks for trying, but yeah, 6% accuracy, not very good. Yeah, so the other topic I wanted to tell you about is another API, another service on top of Google Storage that we call BigQuery. And this has to do with big data. When you start to have lots of data to analyze in your applications, it becomes a pain to build systems to do that. And there are some commercial systems to analyze large volumes of data. At Google, we ran into that issue several years ago when we started to want to do some interactive queries on all the clicks on these ads that are the core of the business model of Google. And so my colleagues have built some ad hoc analysis tool that we just outsourced or that we just started exposing recently under the name BigQuery. And the whole idea is that it's very easy to do SQL-like queries on huge volumes of data, and the responses are instantaneous. The API is a REST API. The data structure is written in JSON, so it's very easy to use even in like JavaScript applications, front-end application, but also any type of back-end systems. It's very fast, super scalable, and I'm just going to show you an example. So now that you saw my small tags example, I'm going to show you how it works with small tags. So the first step to use BigQuery is the same. You just put your data into Google Storage. And the data is in the same format. It's a CSV file. The second step, instead of training a model this time, you're just specifying a schema. So you have another API call that's a REST API call where you say, you pass a JSON data structure that says, this is the schema for my table. So the first field is named this, it's named tag, and the type is string, and the second field is an integer, and the third field will be a text field and all that. So you define the table, and once it's defined and the indexes are computed and all that, you can perform SQL queries from a REST API. SQL, it's like classic SQL. You can do where and group by and all that, but you also have some statistical approximations like top and count distinct. So that's how you would do a query. So you do a get on the table with the table name, or you pass the query as a query string. And then you get the result in JSON format, so you can pass them into any language. It's pretty easy. Okay, so the security uses all the usual Google security methods. There's a great example where they have one of the sample data is the whole Wikipedia changelog, which is a pretty big file. And that allows you to do queries like this. For example, you want the top title, the top 5 titles for which there is the most number of revision. And so that just performs like really fast on the whole data set. Yeah, so you can see the not very surprising. I'm sure it's changing all the time. There's a shell called BQ shell that allows you to do interactive querying. So let me show you that. So I've done that with my I done that with my own example, my own small tag table. I define a JSON schema for it, and then I can do queries. So I have a bunch of queries here that I have pre-canned. So for example, I'm just going to define, like select just all the tags. If I just want the tag list. Okay. Oh, did I? Oh, yeah, I know. I know, my token expired. Give me a break.
I haven't got anything else, Pat.
BQ shell. Or
Actually, I've just put the link for Nick Johnson's demo onto Twitter if people want to look for that as well afterwards.
So I won't show you an interactive show of BigQuery, but basically you can type your queries in BQ shell and you get the result very fast. Another very kind of cool type of use case, think about the number of times where you want to, your boss comes in. Oh, who among you are building enterprise application, by the way? Oh, just a few? Okay. It's very typical in the enterprise where your boss comes to see you and they say, we got this huge amount of data and I want you to build me a reporting application with graphics and all that, and it needs to be a web app with security and all that. Building that kind of stuff with traditional like IT methodology may be expensive and take a long time and all that. Now, with things like where all the data is in the cloud and you leverage all these services, this is an example where we use the previous Wikipedia example. So here we just use Google Spreadsheet, and we have this spreadsheet where we have the search term here in one column, and then an empty table. And here we're using AppScript to be able to pull the result in JSON from a URL, and the result that we're pulling is a query, the query that we saw before, where we are counting the top 5 titles that have the most revision for that query term. And the query term here is parameterized by the spreadsheet, so you type in a name in there like Google, and it will instantly just pull the result from BigQuery without having to like build a server side for it or do some heavy-duty parallel processing. It's all done inside of the Google data center. And then you get all these results, and you can use the visualizations that are part of Google Spreadsheet to do that. So it just lowers the bar of lower the admission bar or the barrier to entry for building this kind of very simple visualizations of data on huge data sets and in a very interactive way. Okay, so I showed you my very nifty example. And then I highly advise to go to Nick Johnson's blog. He has all the code in there. It's a pretty cool, actually I'll tweet that while we're at it. Oh, you did? Oh, excellent. So Simon tweeted it. And that's, yeah, that's kind of it. So as in a summary, to summarize this session, with Google Storage, Google starts to have an offering in infrastructure as a service. It's not commodity storage. It's a little bit more expensive than Amazon, but it has differentiating features like great latency and access control. And in addition to that, it's the entry point into the Google Cloud to leverage services such as prediction, API, and BigQuery that don't exist in other offerings. That's it. Do you have any questions? Yes? For the prediction API, do we provide an XML-based API, or is it just JSON? No, so it's just JSON. But it's very simple anyway, because what you're passing in there is just a JSON data structure. So I don't think you need XML for that. It would be an overkill. You don't need like type data in there. Any other questions? Yes?
Could you expect any easy way how to build a CSV file in Google Spreadsheet actually and send it directly to prediction API?
That's a very good suggestion. So yes, so can you just build the CSV file in a spreadsheet and then send that to the prediction API? So yeah, that's a very good suggestion. Right now, you need to build a CSV file and then push it to Google Storage. In the future, I could imagine that you would just point Google Storage to a spreadsheet directly. They don't have that right now, but it's kind of pretty easy to just make the transition.